Okay, ma'am, started now.
Yes, sir. Yes, thank you all. And it's my immense pleasure to introduce our today's chief guest for the 5 days online ATAL FDP program on research avenues and challenges in Industry 4.0. On behalf of R.M.D. Engineering College and Department of Electronics and Instrumentation Engineering and my own behalf, I welcome our today's chief guest, Dr. Vijayakumar Krishnaswamy, Assistant Professor of Electrical and Electronics Engineering from Indian Institute of Information Technology, Design Manufacturing, Kancheepuram. He completed Bachelor's of Engineering in the stream of Electrical and Electronics Engineering from Coimbatore Institute of Technology, Coimbatore, and he completed M.Tech in Power Systems and PhD in Electrical and Electronics Engineering from National Institute of Technology, Trichy. And sir have a vast experience in research and academic field in terms of various roles like Research Associate at National Institute of Technology, Trichy, Postdoctoral Research Fellow at Nayang National Institute of Technology, Jaipur. And I am happy to share the few distinguished awards and honors received by our today's chief guest here. He is the recipient of IEI Young Engineers Award in the year 2018 for excellence in the field of electrical engineering, and recipient of Young Scientist Award for the Startup Research Grant of rupees 19.9 lakhs from DST SERB Government of India in the year May 2016, and Power System Operation Cooperation Award in the year 2014 by Power Grid Corporation and IIT Delhi for innovation and technology transfer, and the award is being funded by the FITT will function as its nodal agency to implement the program. The objective of this program is to reward the reputed and immediate creative research accomplishment in power system and related fields in the various technical institutes like IITs and NITs, etc. And sir is a visiting professor at University of Saskatchewan, Canada in the year September 2017, and Sastri Indo-Canadian Fellow from Sastri Indo-Canadian Institute funded by CIDA and MHRD in the year 2017 in research collaboration with Canadian universities, and he is a recipient of Vishwesvaraya Young Faculty Research Fellow from the Ministry of Communications and Information Technology, Government of India in the year 2016. Sir received grants from various funding agencies in the following domains: virtual energy storage based demand response algorithm to enhance the performance of the battery energy storage in the smart grid from with the project grant with the worth of 27.45 lakhs in the year 2019 funded by DST, and performance enhancement and reliable operation of wind PV distribution system supplying AC DC loads with remote conditioning monitoring with the value of 19.89 lakhs from the DST SERB in the year 2016 to 19 duration, and development of technologies in the area of renewable energy with the worth of 2 lakhs from Sastri Indo-Canadian Institute at MNIT Jaipur, and design and development of power electronic converter controllers for renewable powered telecommunication systems in the year 2016 with the worth of rupees 37 lakhs, and design and prototype development of efficient wind driven fed induction generator PV hybrid system with smart controller for reliable supply to isolated load with the worth of 30.53 lakhs from the Ministry of New Renewable Energy, Government of India, Jaipur. And he is a reviewer of SERB DST project proposals at DST and reviewer for many SCI indexed journals, IEEE journals, IET, and also the Springers and journals and reputed journals and also conferences. And he is an active member of IEEE, member of IET, and member of Institution Association of Computer Science, and life member of IEI, and life member of ISTE New Delhi. So once again, I welcome you, sir, for this ATAL FDP on research avenues and challenges in Industry 4.0. Welcome, sir. Welcome.
Yeah. Thank you, ma'am. Thanks for the very brief details of mine. At first, good afternoon to all the participants and the coordinators of
Hello.
this program. Hello. Are you hearing me, ma'am?
Yes, sir. Yes, sir.
Hello.
Yeah, sure.
Hello,
Okay,
sir.
sir, sure. Ma'am,
Yes.
are you
Hello.
hearing me?
Ma'am, Badma ma'am, Badma ma'am. Badma ma'am. Sir, you proceed, sir.
Ma'am, sir, my voice is clear now, sir.
Voice
There
is
no
clear,
issue,
sir.
right?
Yeah.
Yeah, sure, sir, sure. Thank you. Thank you, sir, for the invitation. It's my great pleasure
Hello,
to
sir.
be part of this.
Hello.
Yes, ma'am.
Yes.
Badma madam.
Yeah. Yeah, it's okay. Okay, sir. So today we are going to discuss about smart grid technologies. So before going to my talk, just I will share my window with you all. So is my screen is visible to all of you?
Yes, sir.
Yes, sir. Oh, okay. So it's moving now. Is it possible? Is it moving or not moving? Hello. So are you able to see my slide movements?
Yes, sir. We are able to see, sir.
Oh, we can able to see, sir. So when I change the slides, we can able to see, sir.
Yeah. We were able to see, sir.
Now, sir, it's changing, na? Slides are changing, right?
No, sir. Your first slide only we are able to visible, sir.
Okay. I think some problem with my uh, tool. So what I can do is just I can share my entire screen, so that would be better option. Yes. Yeah. Now I think we can able to see, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, sure. Thank you. Thank you. Yeah. Good afternoon to all of you. So in today's discussion, we are going to see the smart grid technologies and how these smart grid technologies will help you out in the Industry 4.0 revolution. So when we talk about the smart grid technologies, most of the time just we can talk about in terms of energy perspective. So that's what just we can say. The smart grid also is comes under the energy perspective. So here, why we need to connect the smart grid with Industry 4.0 means when you are looking at the any manufacturing industry, without electrical energy, we cannot do anything. Electrical energy also is a part of that revolution. So that's what just we we plan to have this session on smart grid technologies. So in the smart grid technologies, how we can enhancing the performance of the energy systems in smart grid, that we are going to discuss, and what is the importance of alternative energy systems like renewables, and the importance of the energy storage in the electrical system, that we are going to discuss in this presentation. If you have any questions or any discussion, please you can ask me in between. So I'll be happy to discuss any point here. So at first, we'll see what is the energy transformation by 2050. So what we can look at the energy scenario in 2050. So in a 2050, they are focusing on to reduce the carbon emissions at least by 70% of today's data. So how we can reduce the carbon emission? Why we are going for reducing the carbon emission means because of the pollution caused by this fossil fuels and all. It creates a lot of pollution to the environment. So that's what just we are moving to the alternative energy sources. So one of the main reason is to reduce the carbon emissions. Then other advantage is to reduce the energy cost. So once you are penetrating the more renewable energies into the system, you can able to reduce the cost of the electricity. For example, if you consider 10 years back, so in a 10 years back, if you want to get a 1 unit of electricity from photovoltaic system, the cost of the installation per unit is, you can roughly say it's 20 to 25 rupees. So just we have to sell 20, 25 rupees, then only you can able to get back your money. So even if you consider the 120 watt panel, photovoltaic panel, in 2010 or in 2007, it almost we can say it's 30,000 to 50,000 rupees. But now, if you are going with 120 watt panel, just we can able to purchase that 120 watt panel for the amount of, we can say, 7,000 to 12,000 rupees. So the panel cost also is, comes down, so that the electricity produced by the photovoltaic systems also it's coming down. So do you have any idea what is the price of the photovoltaic system? Anyone have any idea in this participant side? Or I can say it's a bidding cost. So in India, just we are having the separate ministry for new and renewable energy sources. So that ministry is called MNRE. So the Ministry of New Renewable Energy. If you can browse through this website, MNRE website, you can get to know that what is the minimum cost now. What is the bidding cost of the PV power? So do you have any idea of it? Recently also just there are a lot of discussion about it, right? So now even they are ready to purchase the power from the we can say generation unit set. It's below 2 rupees. So in a below 2 rupees, they are purchasing the power from this powers like Adani Power, Tata Power, and other power companies are there. So they are ready to, the government is ready to buy, or even they are ready to sell the power at below 2 rupees. So that's what we can say. Now the cost of the electricity also is coming down because of the penetration of renewable energy sources. Then when we come into the economic perspective, once the electricity cost is coming down, then your manufacturing cost of any product also comes down. So it's a beneficial to the society. So that's what now we are focusing much on the alternative energy sources. Then the next point, we can able to improve the energy security of the country. So when we come into the energy security, if you look at the energy security perspective, in today's case, almost 80% of the power is generated from the fossil fuel-based power generation units like thermal power plants. So for this thermal power plants, we need resources. So that resources you can take the coal and oil. So this coal and oil we are importing from some developed countries and some EA countries. So once you can think of it, our 80% of the power demand is met by these thermal power stations. So these thermal power stations getting the coal and oil from the developed countries, once they stop to export their coal and oil to India, what will happen? We will be in the shortage of will be in shortage of coal and oil. So what will happen? We cannot able to reduce, we cannot able to generate the electricity to meet your demand. So in that case, just we have to, I mean, even there is some power cuts to the industries, even residential areas. So once there is a power cut to the industries, then their manufacturing will affect. So that country's GDP also will come down. So this is called it's a energy security. So in that case, if we are generating the power from this uh, re- uh, fossil fuel based power stations, then we need to depend on the some countries. But here, once if you are going with the renewable energy sources for meeting the demand, then what will happen? You need not to depending on the any import of the coal and oil. So whatever the demand you required for your buildings, you can able to generate your own power and you can utilize it. So that the energy security of the country can improve. So that's what now people are looking for alternative energy resources. So that's what this PV and wind power systems and all come into the picture. So then this is the case of considering the entire country. So when we come into the energy access, even if you look at India, almost we can say 7 to 8% of the locations or the places it's not connected to the electrical grid. So if that 8% of the places not connected to the grid, so they're not able to access the electricity network. So what will happen? There is no development in the areas. Please, just we can imagine that if you're not having the electrical power supply, so there is no demand on the particular area. So if you are having the abundant power supply, then there is a possibility of industrialization. But if you're not having the proper power supply, then there is no chance of getting the industrial units to that place. So just we can think of hill areas or remote locations. So these renewable energy sources provide the 100% energy access. So here what we can say is even without electrical grid also, by using the wind and photovoltaic system, you can able to design the standalone power supplies to supply your loads. For example, if I want to supply my home, then I can able to design the system by using the photovoltaic system or wind energy converter system or any other renewable energy systems, so that I can able to power up my house. But power up my house or my industry, that's depending upon the application. But what I can do, I can able to electrify the remote areas. So that's what we can say by doing the alternative energy resources, we can able to achieve the 100% energy access, 100% energy access. So on top of all this objective of the energy transformation, the main objective is to create the lot of job opportunity to the citizens. So this is the socio-economic perspective. We can say this energy transformation also plays the crucial role in the socio-economic perspective. So here, by creating the job opportunities, that a lot of persons can get benefit out of it. So this is this is the energy transformation by 2050. So when we come into the renewable energy scenario in 2050, so this is the rough estimation. By 2050, you can see here the first figure, just they have given a year in x-axis and electricity generation, or we can say it's a demand in the y-axis. So at present, we can say it's a 2020 we consider. So almost we can say it's a 27 terawatt hour per year of energy is required for us. So at the same time, by 2050, you can look at it that demand is more than double the current demand. So if I say it's at 27,000 now, almost it's a 55,000 terawatt hour per year is the requirement in 2050. So this demand, how we are going to compensate it? So that's what just you can look at here. They are projecting that in 2050, almost 86% of the power is going to generate from renewable energy sources. So that's what you can see here. They mentioned that in 2050, almost 86% of the power is going to generate from the renewable energy sources, right? So in this 86%, if you look at it in the second graph, if you look at it, so almost 1/3 of, I mean, the 20,000 gigawatt is the installed capacity. So in the 20,000 gigawatt installed capacity, almost 1/5 of the power is going to coming from the wind and photovoltaic system, and 1/3 from the wind and another 1/3 from photovoltaic systems. So here approximately we can say 6,000 gigawatt of the power going to generate from the wind energy conversion system. Then another 8,500 megawatt, sorry, 8,500 gigawatt of the power going to come from the photovoltaic systems, right? So there is a huge opportunity in the development of wind and photovoltaic systems for supplying the whether it's manufacturing industries or in a residential places. Okay, now just we have discussed about the renewable energy sources, the requirement of the energy. Then just we have discussed about the what is the demand and how much of the energy is going to supply from the wind and photovoltaic systems. Now we are coming to the smart grid architecture. So this is the smart grid architecture. In the figure you can see here. I will explain to you one by one. Don't worry about it. I think the participants are from the different discipline, right? So only from electrical engineering perspective or from the different specializations. Yeah, participants, please. Are all of you from the same electrical engineering background or from the different specializations?
No, sir. I am from Electronics and Communications Engineering, sir.
Oh, okay, sir. Okay. Okay. So I think there is a mixture of participants, so that I can explain the things in the layman perspective, so it will be better to understand things here. So if you are not getting any point here, please let me know so that I'll give more clarification on that topics. Right? Okay. So when we come into the normal grid, so what is the grid here? So if I say it's a supply grid, so that supply grid we can say we'll get the constant voltage and constant frequency. Just we are having the industry or any commercial buildings, you'll get the supply. So when you are getting the supply, first they may ask whether it's a three-phase supply or single-phase supply. So if it's a three-phase supply, just we'll have the rated voltage. So the rated voltage you can say it's a 440 volt and the frequency is 50 hertz. Then if it's a single phase, you can say it's a 230 volt, 50 hertz. So here we will have the 4 wires. So in the 4 wires, all 3 are lines and the fourth one is the neutral. So if you are taking the connection between your line and neutral, that will be called phase. So if you are taking the line to line, that means if you are taking from the 2 lines, that will be called a line to line voltage. So that's what in electrical normally we used to say. So in this case, here, just we can take an example of it. From where we are getting the power supply? Just we are getting the power supply. For what purpose we are getting the power supply? Just we want to, just we have to operate your machineries or we have to operate your loads. So this part is called utilization. So from where we are getting this power supply? Anyone have any idea? So in Tamil Nadu, we are getting from the electricity board, TNEB board. So that TNEB board is called distribution, right? So that's a distribution center. So that's a distribution. Then before distribution, we are having the transmission. So they will transmit from the generating point. In a generating point, or you can say it's a generation plant, we are having the thermal power stations, or we are having the photovoltaic power stations, or you can say the wind farm. You can take any source. So just what they are doing, just they are generating the power and they are transmitting from one place to another place. So with the higher voltage, why they are going for higher voltage means to reduce the losses. Then in the receiving end of the transmission lines, just we are having the distribution. That distribution is called primary distribution. So that 110 kV or 222 kV you get, 220 kV you get. So that can be stepped down to 11 kV and 415 volt. So that 11 kV is given directly to the industries, and this 415 volt in some of the MSMEs, medium and small scale industries, they will take the 3-phase line with a 440 volt. And some for residential application, you will get the single phase. So this is the entire structure of the power system. You can say it's a power system. So generation, transmission, distribution, and at the end we are having the loads. So the loads means we are the consumers connected to the distribution system. Okay. Now in earlier days there is no kind of this renewable energy sources, wind and photovoltaic system. So they had only the thermal power stations or nuclear power stations. That they will generate the power. For example, in NLC you are having the generation station, generation plants, and here in Kalpakkam you are having the nuclear power plant. So that they will generate the power and they will transmit to the urban areas or the rural areas to distribute to the consumers. So this is the structure here, right? Okay. So earlier, only one generation stations, that is NLC or we can say it's a nuclear power plant. There you are generating, and the consumers are located at the end of the system. So that means that you can see here, for example, just we are having the nuclear power plants, thermal power plants, and hydro stations. They will generate the power here, and they will transmit. All of them having the transmission lines. They will transmit, and they will. I mean, don't consider the smart grid. Earlier the system anything. Then from transmission to distribution. So here the distribution is connected to the residential loads or factories or we can say it's the building, commercial buildings and all. So these are the three players. But earlier case, only your power flow in one direction. So that means that we are generating the power here, we are transmitting. That also is from right to left. And here distribution stations, they will step down the voltage and they will distribute to the loads. Just here I can say it's industrial loads and residential loads with the step down voltage. Okay, so there is no sources is connected in between. But nowadays, just we are having the photovoltaic and wind energy conversion system. So where this wind energy conversion system and photovoltaic systems are installed, these are located in the remote areas. That too, not lumped. It's not kind of the megawatt level power plants. Even some of them, they may have the 500 kilowatt power station. Then they connected to the distribution network. So these, we can look at here, these wind and photovoltaic systems are not integral part of this generation units. These and all connected in the distribution networks. So wind power plant and solar power, even PV systems, they will connect it to the distribution network. Even though these are the generators, but we will connect them to the distribution systems. So why we are connecting to the distribution system means So this wind and photovoltaic, even nowadays, we are talking about the rooftop photovoltaic systems. So where this rooftop PV systems and all is located? It's located in the different houses. So that different houses where we are connecting, we are connecting to the distribution network, not connecting to the transmission network. So here, how we are managing the energy? That's a question mark here. So whatever the power you are generating in your home, or we can say just in a rooftop, you are having the photovoltaic system. Your daily load requirement, I can say the maximum peak load of your house is, you can say it's a 5 kilowatt. Roughly I'm saying it's a 5 kilowatt. So this 5 kilowatt power is not required all the time for you. So sometimes I may require the 5 kilowatt power during the morning hours. So then after half an hour, just I can switch off my geyser or my stoves and all, so that my load can reduce to 2 kilowatt. But thing is, just how you design the photovoltaic system for your home? That's a question mark. So for that, first we have to decide what is the peak load requirement of the buildings. I can say for my industry or for my home, I require the 5 kilowatt power. So that 5 kilowatt power, just we can say that's a maximum demand. So how can I design the photovoltaic system with a battery storage mix? Just I can go with the 30, I mean, normally in the distribution system, normally they'll say it's a 20% limitation. But as per the load of my home, I can go with the 120% of the, we can say the ratings. So that 120% I can design here. So sometimes my load is not even 100%, even I can say 60%. So where the excess energy go? So that excess energy, if we are connecting to the distribution network, so that excess power or energy go through the distribution network through some other loads. The same way, you may have the 400 houses in your, we can say it's in the housings. So in the 400 housings, all the time these 400 housings may not have the peak load. Some houses may have the load, some houses may not have the load. So that time just the energy can be shared between the homes, right? So this is a case of the rooftop photovoltaic system. So for the rooftop photovoltaic systems, you do not require any battery storage systems. Why? Because whatever the power generated from another home, that can be shared by the nearby home. So there is no energy storage devices in the rooftop photovoltaic systems. But think of it, this is a standalone power. You are designing the standalone power supply by using the photovoltaic panels. So in that case, the design considerations are different than the grid connected system. So here, if you are having the excess energy, we cannot able to send it to the any network. That energy, you have to store it in your battery, so that energy can be replaced whenever we are having the deficient power from the photovoltaic systems. So for that purpose, you should have the battery energy storage system in the standalone system. Standalone system means just you are having the small, small photovoltaic system or wind energy economic system. By using that small wind energy economic system or photovoltaic system, you are supplying to your loads at your home or loads at your industry. So in that case, just use for giving the continuous power supply to your loads, you should have the battery energy storage system in between your source and the load, right? So in that case, you have to use the battery energy storage for the standalone applications. Any clarification with the rooftop photovoltaic system? Yes. Yeah. Here, one more thing I want to reveal. So this photovoltaic system and wind energy conversion system, we are connecting to the distribution network. So that's what this wind and photovoltaic systems are called, distributed generation units. So normally we'll call it as a distributed generation units. So here, these are connected in the distribution network. So another thing, nowadays we are discussing about the electric vehicles. So where we are having the electric vehicles, just if you want to charge your vehicle, just you have to connect it to your network to charge. Am I right? So we are connecting all the, I mean, here I said is a 40 homes. These all 40 homes connected to the distribution network. This all the people in the 40 houses, they are having the electric vehicles. So in 40 houses, each house having the electric vehicles. So there's a some disturbance from some participant. I don't know. I think, yeah, now it's okay. So, any messages? I will check it in any special. Please, if you're having any questions, please turn on your mic. Otherwise, please you can mute yourself. Right? Okay. So here, when we come into the electric vehicles, so all 40 houses you are having the electric vehicles. So what will happen? For example, I mean, okay, I'll put some question to you. If I'm having a vehicle, just you can say it's a four-wheeler. So how much time you are using your vehicle? I can say monthly time. If you're taking the monthly time period, so how long you will use your car for driving? Any of you can answer? Any rough calculations? It's okay. Yes. Yes. Any idea? So almost we'll use only 20% of the time to drive our vehicle. So 80% of the time the vehicle is parked in our home, or it may be parked in a our office. So that's what we can say. These electric vehicles also will be considered as a energy storage system. So what we can do is just take these 40 houses. These 40 electric vehicles are parked in the houses. So that may be connected to the network. So once it's connected to the network, just we can, I mean, why we are connecting to the network means for charging. So here in the electric vehicles, you'll have the bidirectional power converters. So depending upon the state of charge of the battery, whether the battery can discharge or charge. So you can say my SOC is 50%. So that time just I can prefer to charge my batteries. When my SOC is more than 50%, then I prefer to discharge the batteries whenever the load demand is more. We can say during the peak load demand or peak load condition. So in this, even the distribution network, we should have the variable tariff. So if you're having the variable tariff during the low peak period, the price of the electricity is less. During the peak hour, your electricity price is higher. So there is a simple concept of just buying at lower price and selling at higher price. So during that low peak period, you can use to charge the batteries, so that just you are purchasing the electricity at a less cost. During the peak hour, the electricity cost may be doubled or tripled. So that time you can charge your, you can discharge your batteries, selling the power to the utility. The same concept of Ola Uber. So whenever the demand is high, then your price, the fare of your Ola or Uber is double the times or triple the times. So the same way, during the peak hour, the price is higher, so that whoever stored the energy, they will release the energy. That means discharge the energy to get the profit margin out of the tariffs. So this and all, we are expecting that we should have the variable tariff plan. But nowadays, just we are having the fixed tariff. So this fixed tariff will not motivate the consumers to participate in the demand response management algorithms. So demand response management means it's a simple. So here, the demand, just if you are having any system you can take, so your input must be equal to the output. That means including the losses in the output. So here also, if you are having the supply, then that means just we are having the energy resources. So whatever the power you are generating, that should be matched with the demand. But here, the source also is a variable one, and demand also is variable one. So it is not possible to meet the supply and demand. So that time you should have the battery energy storage systems. So that's what nowadays just we are incorporating the energy storage systems into the electrical grid. Okay. So when we come into the cities and offices. So when we come into the cities and offices, now just we are moving to the smart cities, smart buildings and all. So in the smart cities, smart buildings, or we can say in the smart offices, just the main perspective, the main, we can say the main objective of this smart cities or smart system is to reduce the energy consumption, to reduce the energy consumption. So these buildings and offices also planned in that way to reduce the demand, energy demand. So how we can reduce the energy demand means, for simply I can say one story out of it. Here, if you consider this office buildings or in a building, high-rise buildings, we may consider as a residential buildings also. So if it's a 20-floor building, so in the each floor we can have the 4 houses. So 20 into 4, so we can say almost 80 houses in that building. So on all 80 houses, they will use the refrigerators and the air conditioners. So this air conditioners and these refrigerators will consider as a loads, or we can say is sources, or some these refrigerators and air conditioners they are having in your network. So this will be considered as a load or source. Anyone? So normally we will consider as a load, because once if you switch on the air conditioner or refrigerator, you will get more electricity bill. So normally just we will consider as a loads. So how many of you know that these refrigerators and air conditioners, we can make it as a storage system? So shall we make it as a storage system, this refrigerators and air conditioners? Yes, of course. Why? Because these and all thermally just we are storing the energy. So just here it's convert the electrical energy into heat energy. We can say it's cooling, right? So just we are increasing the temperature. So for example, if you make the 25 degrees centigrade, so if your temperature is 30, then that will bring the temperature to 25 degrees centigrade by operating as a load. So here, these refrigerators and air conditioners you can make it as a energy storage devices. So how means, for example, if you take the variable tariff system, in a variable tariff system, just you can turn on your refrigerator, so then you can keep 25 degrees centigrade. So that time your electricity price is lower. So during that time, it's 25 degrees centigrade, you can make it at 24 degrees centigrade. Even I can able to withstand, or you can say it's up to 20 degrees centigrade, I can able to withstand that cooling. So what I can do is, for that, I'll make 20 degree, because during the low peak period, the electricity cost is very less. So that time, just I'm storing as a cooling in my room. So whenever the peak demand goes higher, my price of the electricity also will go higher. So that time, what you can do is, you can completely turn off your air conditioner or refrigerator, so that you are not consuming any power from the utilities, so that you can say, these strategies we can play with the demand response management of the system. So what will happen? Just the same thing. Whenever the price is lower, just we are making 5 degrees centigrade less, so I can able to withstand that cooling also. So just I'm storing of that 5 degree. Then whenever the electricity price goes higher, then what I can do is completely I turn off the air conditioner. So my room temperature is now 20. So it may take 5 to 10 minutes to reach the 25 degree centigrade. So that time my price may change. That means my price may come down. So during that time, I can use that electricity again to cool my room. So in that way, you can able to make your refrigerators and air conditioners as a storage devices in the smart grid architecture. Okay, now if you may ask me, so for 5 degrees centigrade, it's very less. So you can think of it, for one house, it's very less. Now just we are having the 40 houses in your apartment. So if all the 40 or 80 participants or 80 consumers, they play in that way, then you can able to save the huge amount of energy. So that's what now we are moving to this smart, we can say the smart cities and smart buildings. Even few people talk about zero consuming buildings and all, right? So these are all now booming up because of this smart grid architecture. So here, the main reason to go with smart grid architecture is to reduce the energy consumption. So that's a very big objective in the smart grid architecture. So any questions on this architecture? So once you're very clear with this architecture, then it will be very easy to understand why we need smart grid and what are the components it's employed in this smart grid and how it can be automized. So how we can able to automize the entire system. So once if you are automized your electrical grid, now at present grid, that will be called as a smart grid, right? So here, these are the components of the smart grid architecture and their functions. If you have any questions, specific questions on this smart grid architecture, please post the questions here. So I'll go back to the chat box. If you have any questions, then I'll clarify, then I guess. Any clarifications or any doubts? Any questions? Okay, so now we are talking about the automation of this all the resources and loads. So how we can do the automation or how we can achieve these functions? I told you, no. So whenever the electricity price is higher, just you can sell your power by discharging your batteries or no, discharging the batteries of EVs. Whenever we are having the electricity price is lower during low peak period, you can charge your batteries. So that's what we are discussing. So who will do this job? Whether I am a person, if I am a car owner, shall I stand in front of my car and I can monitor the charging pattern of my car? So whenever the price comes down, then I can I can give the order to my car to sell off. Or whenever the price is low, can I give order to my car to charge? No. So these processes and all happen automatically. That means just we have to automate this process. So how we can automate this process here? That's a question mark here. So any idea how we can do the just automation of this charging? Or I told you about smart buildings, or we can say smart homes. So how we can achieve it? Yes, any idea? Very simple. Just now we are talking about the technology that's called Internet of Things, IoT. Normally we call it as the IoT. So by using the IoT, we can able to automate this power grid so that we can able to enhance the efficiency of the we can say the supply system. So what is the role of IoT in smart grid? So before going to the application of IoT in the smart grid, we'll see what is IoT. So that's what I told you, it's the Internet of Things. So before this Internet of Things, earlier, just we are having the various technologies. By using that various technologies, they have tried to improve the system performance. So in this case, first we'll talk about the communication perspective. The communication perspective, earlier just they had the passive communication. So here, the passive communication. So in the passive communication, just you can consider the RFID, or you're having the QR code on any product. So whenever you require or whenever you want the information from my side, I can read my RFID tag, or I can scan the QR code and I can get the information from it. So this type of communication is called passive communication. When we come into the active communication, communicate when it's needed. So for example, if in your home, you are having the home automation. So in the home automation, just you are having, for example, just you need some information of any particular device. So that time you can send the command to that particular device, then you can get the information from that. So that just you are having any sensors, what are the parameters required. So that particular type of sensors may be located in the system. So just you can send the command and we can get the information. So this type of communication is called active. So now just we are including the awareness to the system. For example, nowadays, if you look at your mobile, just if you're having any kind of clarification from the customer care, at the first step, you need not speak to the executives. So they have the automated system. So whatever the query you can have, just you can type it on that chat box. So your robot can answer. Robots are answering to your queries. So that's what we are doing is just we are making the awareness to the machines, so that machines can interact with the human. So that's what that kind of thing is called action based on the simple computation. That action will be based on the simple computation. Then the best example, your mobile customer care or telehealth and everything, is a fifth sense. We have included the fifth sense. Then recently, just we are come up with a lot of VAs and big data. So we can able to take the decisions based on the rules. Just we are training the system, whether it's a smart grid, electric vehicle, or any kind of industry. First, we are training the model. Then that model can take the decisions based on the rules. So, best example of this autonomous systems are, we can say it's driverless cars. Nowadays, it's getting popular, or we can say it's a self-driven cars. Even the smart grid also is the best example to incorporate this AI and all into the system to make the grid smarter. Okay, can I take 2 minutes break and continue? Shall we take 2 minutes break?
Yes, sir. Yes, sir.
Yeah, sure.
Yes, sir.
So if in between, if you're having any questions, please note it down. I'll come and answer to you.
Participants, if you have any doubt regarding smart grid research avenues, you please put your doubts in the chat box.
Yeah, hello.
Yes, sir.
Any questions?
Yes, sir.
Any questions from participants? Participant might not know.
Yes. No, sir. We are having only the positive feedback. Nice session. So still now we
Okay.
don't have any questions, sir.
Okay. 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 Shall I proceed now?
Yes, sir.
Okay. So when we come to the IoT, so what are the popular fields to implement this IoT Internet of Things? So these are the top 10, 10 most applications. So when we come into that home, so majorly just we are focusing on the smart homes. So what is a smart home? This IoT can be useful in making our homes smarter. So just we can think of it. Earlier in our homes, we do not have internet, or earlier just we have only wired phones. There is no wireless phones. Now we get into the wireless phones, even just we are having a lot of data packs, we are using it. Okay. And the other thing, when we come into the television, so earlier days, just we used to watch some TV channels by using the dish antennas, then the DTH come into the place, and cables and everything. Now there are a lot of OTT platforms, right? OTT platforms like Netflix, Amazon, even Hotstar and all. Just we are watching the apps. So how, just we can think of it, how this OTT platforms significantly growing nowadays. The reason is because of the communication development. That means just we are having a lot of data. So that data you are using for your OTT platforms. Then DTH, I mean the DTH now, if you see the DTH, ATAL DTH, the ATAL DTH itself, they come up with the DTH ATAL Extreme Box, I think. The ATAL Extreme Box, you are having both OTT platforms and you can watch your TV channels. At the same time, this box, this Extreme Box, you can connect with your internet, like your home Wi-Fi. You are having a home Wi-Fi, you can connect to the Wi-Fi network. So your TV is connected. Now your mobile also, just you are using it. So your mobile also is connected, and your laptop system is connected with the same Wi-Fi. And even if you are having any smart refrigerators or smart air conditioners, that also may be connected to your Wi-Fi. So you can able to access any devices in the network. So you can easily able to access all the networks. Even with the same switchboard. Nowadays we are coming up with smart switchboards. That means they are having the Wi-Fi enabled switches. So just we simply can remove the normal switches or manual switches in our home, and we can purchase that smart switches, and we can simply connect it to it. So once you connect, once you replace with the smart switches with your switches in your home, then that switch box will be Wi-Fi enabled. So that will be connected to your home Wi-Fi. So if wherever you are, you can able to connect with, you can able to access your lights, fans, even air conditioner, every devices in your home, right? So that's what this industry is booming nowadays. Even there is a lot of scope for research as well as product development and entrepreneurship. So this area you can able to focus on it. And not only what we can say, your DTH or your smart TV, you can able to connect all your gadgets and appliances, so that you can able to control your appliances from the mobile phone or wherever you are. You can just, you are in Delhi or Bombay or in any other country, you can able to access all your devices in your phone. Right? So that kind of thing. Again, the problem with security. So that's what the cyber security entails growing nowadays. Even not only in this area, even in the smart manufacturing also, there is some intrusion from the outsiders, so that your manufacturing process may get affected. So for that also, just we need to enhance the system security, or we can say it's a network security. So people are working on the network security perspective also, right? Even very simple, we can talk about the OTT platforms. In OTT platforms, if they say we can able to log in with only the 2 devices, you can only able to log in with only that 2 devices. You cannot able to log in with any other devices or any other, you cannot able to cheat that much in the OTT platforms. So that kind of technology is also coming to the picture. At the same time, people are working on the security perspective. Then second one, wearables. What is the best example of wearables? Anyone having any idea about it? The wristwatches. Earlier days, why we have used the wristwatches? Only just you can see the time. But nowadays, just we are getting the Fitbit watches, right? So once you are having the Fitbit watches, you can able to see the time, as well as you can able to pair your watch with your mobile phone. If you are getting any call or any messages, you can able to see it in your watch itself. That's one thing. Then another thing, you can able to see the pulse rate of your body. So that also you can able to sense by using that Fitbit watches. Then if you're going walking, how many steps you have walked, and how many calories you have burned, and even whether we, how many times even that can remind you to drink the water. This information you can transfer to the app, so that will be available for a 6 months period or 1 year period. So by analyzing that, we can able to monitor your health. So that and that is possible. So that's what this because of this IoTs, because of the IoTs, this Fitbit watch central is getting popular now. Even how many hours you slept, whether you slept good or your slept is bad, everything it will. I mean, that means with a lot of sensors, you are making that watch very smarter, so that can tell you whether you had a very good sleep yesterday night or not, and how much time you have to sleep and all. That watches can give the information. So because all this and all because of the IoT, Internet of Things. Then another thing, smart cities. So smart cities, you are having the different types of energy sources, like just we are having the gas connection, water connection, electricity connection, even broadband, telephone connection. So for this and all, it comes under the smart city project. So here also the IoT also, by using this IoT, you can able to make your system smarter. And smart grid. The 28% of the IoT devices using the smart grid technologies, and another 25% of this technology is used in industrial internet. Industrial internet is nothing but here just we are using the different protocol for your system. If you're going to the industry, they will use protocols depending upon the requirements. So that's the industrial internet. Why? Because this industrial internet is very important. You should not leak any information from your network. So for that purpose, they have different types of protocols over there. Then when we come into the connected cars, so even at present also, if we are going to BMW or Audi cars, so if any BMW cars is near to you within a kilometer or within 5 kilometers, that will give you the idea where the another car is running near to you. So that kind of connected car technologies also, this IoT plays a huge role. Even driverless cars. So in driverless cars also, just we need a lot of sensing systems, as well as the communication between the devices also is very important. So this IoT plays a huge role in the connected cars also. Then when we come into the healthcare, yeah, of course, the other 6% of the IoT into the healthcare, retail, and supply smart supply chain. So the majority is going to the smartphone, wearables, and smart city. So why the IoT is getting popular now? The main reasons are cheap sensors. That means earlier case, if you want to measure the voltage and current, at least you have to spend 1,000 rupees. 1,000 for voltage sensor and 500 up to 800 for current sensors. So almost we have to spend 1,800 rupees for sensing the voltage and current. But now that sensors coming into the 1/3 of the price. So even any sensors, even you can think of it, what are the sensors you are using in your daily life, that sensors price and all is coming down. So that's the reason the IoT is growing. And another thing is cheap bandwidth. Just we are having a lot of network bandwidth. So that also is forces to use the technology. And when we come into the processors, even earlier in your mobile or your computers, the processing speed is very slow. Once you make one click, just you have to wait for 2 or 3 seconds to get the response of it. But now, just we are having the very high speed processors. So because of this very high speed process, you can able to do the large number of calculations, mathematical calculations, so that taking the decisions in terms of nanoseconds and milliseconds. So that also is coming cheaper nowadays. So that's what there are a lot of IoT devices in every industries. Then smartphones, yeah. Earlier cases, if you want, I mean, when we talk about the smartphone, what we are saying, just we can say that from the phone itself, we can able to control all the devices. So the smartphones plays a huge role nowadays. Even think of it, without smartphone, we can survive for another 1 month or 6 months. No, never possible, right? So there are a lot of, even if you want to do the transfer, immediately you can do the transfer, bank transfer, or if you want to communicate with anyone in the world, it's very cheaper solutions because of the smartphones. At the same time, now we are getting to the wireless coverage. That's what, once the smartphones are increasing, then we have to provide the lot of wireless coverage. So that's what you can see, that there are a lot of players coming to the picture, like even Mukesh Ambani also is injecting a lot of amount to develop the Geo. Even Bharti Airtel, Vodafone Idea are playing the huge role in India for wireless coverage. Because of this, all the sensors, bandwidth, processors, and all, just we are creating the large number of data. So if you're creating a large number of data, just we have to get some very good information by processing data. That's very much important. By having the data alone will not help you out. So what is the meaningful information you are getting out of that huge amount of data? That is very important. So that's what data analytics also is playing a huge role in the making the systems smarter. So here, when we talk about the IoT, we can say the IoT can be used to connect any object in the network. You can see here, just we are having the multiple objects. So this, because of this IoT, we can able to interconnect all the devices in the network. So why we are connecting to the each and every devices means to exchange the information between the one device to another device. So the main reason is to exchange the information between the one device to another device. So if I am having my smartphone, I am connecting to the Wi-Fi, my TV is also connected to the same network, my refrigerator. So that by using one, I can send a command from my cell phone, so that can be implemented over there. So whatever the information over there, for example, temperature, humidity, and everything can be sent to the from one device to another device. The same way, just we are exchanging the information by doing the communication among all the devices. So why we are doing it? To monitor the entire system. So once all the devices in the system is interconnected, we can easily able to monitor it. At the same time, we can able to track the each and every devices in our system. So that also is very important here. So you can monitor, track each and every devices in your system. And another thing is easily you can able to manage or control the each and every devices in the system. So accordingly, just we have the priorities. Based on the priority, you can able to control the devices in the system. So when we come into the IoT, normally just they will focus on things oriented. That will be on oriented. That's a communication protocol among all the devices, and firmware oriented. So each and every devices in your system, they're having the firmware. That firmware should support to connect with the network. So that's very important. So that's what we can say, the semantic oriented, or we can say it's a firmware oriented. So in earlier cases, the communication in one research area, and the power is in another area. So earlier the power is generation, transmission, and it's a distribution. So this is the utilities. So here the communication also, just we are having the wireless communication and wired communication. So earlier these two areas are, I mean, the people are worked individually. So now for communication also, it needs some application. And here in the grid also, the normal power system, or we can say in the power system also, you need the automation. So if you want to do the automation in the power system, and this communication also requires some application. So what we can do is just we simply can merge these two, so that whatever communications are there, you can apply it to the power system. So once you apply into the power system, then your grid will be automated. The grid will be automated. Then you can call it as a smart grid. So in the smart grid, each and every devices are interconnected. So whatever the information or whatever the control you have to do, you can easily can perform it without any intervention from the people. So that we can do it by using the smart grid. So even there is different types of definitions for the smart grid. So just here I have given. So as per US Department of Energy, smart grid is the intelligent grid that integrates all the technologies for sensing, control, communication among all the devices. So whether in a electrical grid, we can say the communication between the transmission and distribution system, or we can say the between the transmission and the generation system, or between distribution to consumer system, everything at consumer level. We can say any kind of levels. So here the main thing is sensing. So for sensing, you need more number of sensors and control it. So control communication. So how we can achieve the control means by using the communication. So when we say it's a smart grid, that makes decisions themselves. So once all the devices are interconnected and can able to communicate to each other, then easily it can take the decision. So how means by sensing. So each and every parameter of your systems will be sensed. So here the voltages, currents, frequency, every information at every level is sensed, right? Then because of this, you can able to implement the demand response management algorithms, or just you can able to optimize the energy utilization. So by doing that, you can able to make your power system as clean and green. So clean and green means you are enhancing the participation of the renewable energy sources in your system by using this all the automations, right? All the automation means by using the IoT, you can able to communicate between each and every devices, so that the information will be exchanged, so that we can it will be very easy for us to take the decisions based on the actions. We can say the smart grid will be clean and greener, right? So by doing that, we can able to enhance the efficiency of the system. That also is main important. That's what we are doing a lot of integration of the IoT into the power system. So even just we are having some, we have to spend some capital for the integration of the IoT into the power system. However, in this case, just we are enhancing the efficiency. Once you are enhancing the efficiency, you can able to get back your money within a year or within 2 years of time, right? So that's what just you can see by incorporating this IoT into the power system, you can enhance the efficiency of the system so that the entire system will be called autonomous system. So once you can make your system intelligent by incorporating this IoT and technologies, then it can become autonomous. So the system is called autonomous system. So that autonomous system means that system itself can able to take the decisions. So what are the features of this smart grid means? The first one is self-healing. Self-healing means here, if any fault happen, there will not be any disturbance in the supplying the power supply to the consumers. So your intelligent system itself can, because it's sensing all the information in your grid. So by using that information, the system itself can take the decisions. So can take the decisions and sort it out the problems in the network so that the consumer can get the continuous power supply. So that's what we can call it as a self-healing. So your grid itself, it's a self-healing. So here we have to improve the network system from cyber attacks. So for that, just we have to incorporate some cyber security, protection, so that can enhance the loss of information or intruders to do some malfunctions in the system. So that's very much important. Even by making the grid smarter, the consumers can play the huge role. That means the consumers can actively participate in the system, right? So that and all is coming under the demand response management algorithm. At the same time, in earlier cases, just we are having the generation, transmission, distribution, and utility, the loads. But now, because of this smart grid technologies, we can able to incorporate all the generation and storage options to the system. So once you can able to adapt all the generation and storage, then the penetration of this generation and storage will be 20%, not 100%. If it's 100%, then there is a possibility to lead to stability issues. So that's what normally for distributed generation source integrations, they will put a cap of 20%. So because of this, just we can able to open up the new electricity market. That's what I told you. Once you are having your EV and that EV is automated, if you are connecting your EV to the charging point, whenever the electricity is less, then your car will be charged. During the peak hours, you can sell your energy from the battery to the network so that you can able to gain. Why? Because during the peak hour, the tariff will be higher, tariff price is higher. So that during the low peak hour, the price is low, that time you are purchasing the power from the network and storing it. So whenever the demand is rising during the peak hour, the price is higher, so that with the high price, you can sell the power so that you can get a profit out of it. So that kind of opportunities are available in the electricity market. Apart from all this, once you are integrating the IoT devices into the power system, you can able to optimize the asset utilization. For example, you need not once if you are making the IoT, you can able to save we can say some little bit of 5% to 10% of energy. So that can where that can reflect means sometimes the government plan to install the new power plants. So that time your requirement will be cut down. That means instead of installing that new power plant for within a 6 months, you can take up at 1 year or 1.5 months, because just we are optimizing the energy usage here. So that and all is a good sign for the industry. Apart from this, because of this automation of your electrical grid, that will give the quality power to the consumers. The quality power means not only the interrupted power, not only the uninterrupted power to your loads, the quality of your voltage, or you can say the power supply, so that your equipments or your machineries do not operate, is not malfunction. So for that, we need to, give the quality power. So because of this automation, it is possible. So apart from all, we can able to enhance the efficiency of the system. That's very much important. So operating efficiency will be improved by incorporating the IoT in smart grid technology, not smart grid technology, the power systems. So when we talk about smart grid paradigm, this is the structure here. On top of it, just we are having the information flow. You can check it here, how the information is flowing. So first we'll start from the consumer point. In a consumer, you are having the home Wi-Fi. That home Wi-Fi is connected to all the devices for electric vehicle, oven, refrigerators, washing machine, air conditioners, and in your home you are having the the smart meter, that's the electric energy meter. That and all is connected. So once we can able to access the energy meter, you can get all the information, how much power it's consuming per day, how much energy is consumed, what are the devices are switched on, what are the devices are switched off. Every information you can able to get it by accessing the information from this smart meter. So in this smart meter, just we are having the home area network. All the devices are connected. So this will be called as the HAN, home area network. So these informations will be sent it to the distribution board. So in the distribution, also having the all the information. So that like this, you are having the 100 houses in your area. This all 100 houses information will go to the distribution operator. So that's what that network. In the same way, in every area, we are having 40 houses, 40 houses. That all 40 houses, each area will be connected in that network. So that's what this will be called as a neighbor area network. So in that information flow, you can check it here, all are bidirectional. So even the consumer get information from the generating units, even generating units can get information from the consumer. So here the data is bidirectional. But when we come into the power flow, if you look at the power flow is unidirectional from generation to distribution. So generation, transmission, distribution. But when we come into the between the consumption and distribution, that's a bidirectional. Why? Because I already told you, when we talk about the distributed generation sources, always we will connect it to the distribution networks. So because of that, they mention is a unidirectional. So whenever the deficit power, your home can take the supply from the distribution. So whenever your home having the excess power, that can be transferred to the distribution, right? So that's what here we are mentioning the bidirectional. Why? Because DGs, distributed generation, is normally connected to the distribution network. Then here, just we are having the wide area network. The wide area network covers the transmission and generation. So this is a wide area network is a backbone of the communication between the control centers and the generation layers. So here, smart distribution. So whenever we are talking about the smart distribution, normally we'll call it as a smart patrol. It's a patrol system. Just we are using this IoTs for monitoring the system as well as getting information from the system. So that's what we can say. It's that smart distribution also will be called as a smart patrol. So if any faults or any abnormalities happen in the network, that can be solved in the system itself, or it can be monitored and it can pass it to the generation unit. So these are the role of smart distribution. So when we come into the WAN, wide area network, is in the generation and this transmission level. So you can see here, if any fault or fault happened between the conductors or any failure in the net tower, so that information can be passed to your control center. So by doing this, you can able to enhance the safety of the towers from the we can say any damage or any unsafe construction and all. At the same time, you can able to monitor the transmission lines by measuring the gap between the conductors and temperature and everything. Please mute your mic if you are not having any questions. And suppose if any severe fault happen, then the control center send the information so that they can able to island the some portion of your network. That can be possible in the WAN. So these are the IoT gateways. So when we come into the IoT gateways, so just we are having IoT gateway is a kind of processor that will collect all the information and can pass it to the server, right? So here we can say here IoT gateway. So here every distributed generation servers as well as consumer CVs are connected. So that information can be passed to your server. Then the server can send only the record information to the utility regulators and market retailers, so that based on the information they will take some decisions and can able to control the network. So when we any questions up to now, if you're having any questions, I'll take it up.
Sir, I'm having one question, sir. Sorry for interrupting, sir.
So no problem. That's what just I stopped at this point. Please go ahead.
Sir, actually, I was very impressed with your presentation on IoT on smart grid, sir. So I want to know that if you're going for an IoT smart grid, in customer point of view, for example, I am the customer having the small distribution center microgrid. In that case, can you suggest me, sir, what kind of things to be customized at my end to have the energy monitoring system at my end, sir, for customer end, sir?
So for example, no, just we can consider our home, because IoT plays a huge role in the smart home application, right?
Yes, sir. Yes, sir.
So in this case, for example, as a consumer, my foremost priority is to monitor. For example, per day, how much of energy is consumed.
Yes,
so
sir. Yes,
what
sir.
are the devices are on. So for that purpose, just we can have the simply can integrate with your smart meter. Just nowadays they are having the smart meters. So just we can collect the information from the smart meter, and you can create some GUI in the mobile app. There are a lot of apps. Even nowadays, Samsung and Wipro and all, they are working on the smart home project. So what they are doing is they are having the GUI. Once you open the GUI, you can able to see how much of energy is consumed. I mean, what is the expectation? I mean, monthly bill expectation. What is the unit price? Then what are the devices are on in your home? These kind of services, they are already is available, but there are huge opportunities by considering the population in our country. For example, no, a few years back, they talk about mobile. I mean, first they think that we cannot able to communicate without wire. Then mobile phones came into the picture. Thereafter, now we switched into the smartphones. The same way, every day nowadays, just we are more, interested in this technologies. So that's what even it may happen soon. Even you can able to control your air conditioners, refrigerators, even any equipment in your home. You can able to control by using the smartphone, right? So once all the equipments are connected in the same Wi-Fi network. Now we are connecting our TV only with that Wi-Fi network. I mean TV, mobile, and laptop. But in future, all the gadgets and appliances can able to connect with the same network. So in that case, you can easily able to control these devices. Even your home security system, everything will be interconnected. So then you can give as a solution, one solution to your consumer. So you can make it as a product. This as a product. So then we can sell it out. Then just we can able to make some good product to the consumers. So this is a small project. The same way, you may think about the industry. Even in an industry, they may use different kind of protocols, communication protocols. That's what the industrial Internet of Things. People are talking about the industrial Internet of Things. So this way, just we can look into it.
Okay. Thank you, sir. Thank you for briefing, sir. Thank you, sir.
Okay, sir. Welcome. Okay. So when we come into this application of IoT, just I already told you, to monitor the equipments and collect the information from the different devices in the network. By collecting the information from the different networks, you can able to control the grid, as well as you can able to control the devices in your system. So these are already we have discussed, so that I can put it in the flow chart. You can go through it. So HAN, home area network, that can be used to collect the information and control the equipments in the home. And NAN, neighborhood area network, it's in the distribution level. Then WAN can be used in the generation and transmission level, right? So there are a lot of devices, different devices. Then just we have to need some management and control of these devices in the particular region. So for that, you can able to use this kind of technologies. Okay, so smart cities and smart grids are there. There just we can use a lot of IoT solutions. Even when we talk about the smart city, just we are having the different energy resources. For example, water supply. Just we can have telephone connections, cable connections. Even when we talk about transportation. So every system you can able to connect with your IoT, so that you can able to make your city as sustainable and smart city. So in a buildings and home IoT solutions, you are having the different types of appliances, and you're having the different types of equipments. So depending upon the requirement, we can go into that. And the designing of the system also is very important point of view. Okay, so here net metering. Now people are talking about the net metering concept. So net metering concept is very simple. If you're having the excess power, that excess power from the rooftop, if you are having the excess power, that excess power you can credit to the utility services. So whenever the PV is not available, then you have to take the power from the utility. So that time, just you can able to calculate how much time just we have supplied to the utility and how much time you have drawn the power from the utility. So based on that, monthly, if you look at that energy consumption
Sir,
of
sorry
the
for
home.
interruption, sir.
So
Sir, sorry for interruption, sir.
if we have consumed more, yeah, please.
So actually,
Please.
continuous noise is coming, sir. We are unable to follow you, sir.
Yeah, exactly. I think from
Yes,
someone else.
yes, sir. Sorry, sir. We will sort out, sir. We will sort out.
Please,
Yeah.
please.
Sir, Arvind, please
I
unmute,
don't
sir.
know.
Arvind, sir,
All of
mute.
you, please unmute.
Made unmute, ma'am. Made unmute.
Yeah, now it's okay. So depending upon the energy consumption, if we have consumed more energy from the utility, you will get the positive number. If we have supplied more energy to the utility from the home, then you will get the negative number. So if you are getting the negative number, that means that your distributor need to pay the money to you. So if you are getting a positive, only for that positive points you have to pay to the electricity board. So that's what net metering is helpful when you are having the rooftop system in your home. So when we come into this, smart grid system, so that's what I told you earlier. Just we are having only the power system, and communication system is in the another way of, or we can say it's another research area. But now they have merged this power and communication. Now you can able to make your system as smarter. So here, when we come into this power flow in this way, just we are having a home. In the home, you are having the rooftop photovoltaic panels and battery and inverter. So in that one is connected to the gateway. So this gateway can collect all the information, how much of energy produced and how much energy it can drawn from the network, and every information, or the voltage, frequency level, every information can be passed to the cloud. The same way, just in the if you're having the photovoltaic plants, so from each and every plant, we are having the cloud gateway. So from that cloud gateway, that can be passed to the cloud storage. So once here you are having the huge number of data. So for mining or to analyze the data, we can get the very much useful information. By using that information, you can able to give alerts, or you can make some intelligent algorithms to take the decisions, or you can show up that information, the dashboards, or can give it as a reports. So that and all is possible. So it's a kind of automation, right? So by doing the automation of your power system, your grid will become a smart grid. Why smart grid means? For enhancing the efficiency and performance of the grid. So what are the challenges? So when we come into the smart grid, there are a lot of challenges. That's what I told you. And then data, we are having a very huge volume of data. So how we are getting the useful information by mining or by applying the analytics into this data? That is the question mark here. So that's what you need to get the very good useful information out of the large number of data. That's what they are saying. It's a volume, variety. You are having different variety of data. So by taking the 2 or 3 variety of data, you can able to get another variable, right? So by doing some mathematical operations. So that is possible here. So variety and velocity. How often you are getting the data? That's the sampling, depending upon the sampling time and everything. So this is one of the challenge in the smart grid. And another challenge in the smart grid is security. I already told you, each and every devices in your home is connected in the common network. If any intruders come into the picture, they can able to do the malfunction of each and every equipment appliances in your home. So that can lead to damage your home or damage your, we can say damage your particular equipment. That may happen. So for that, the security is the another challenge in the smartphone or smart grid in the smart grid technology. Another thing for implementing this technologies, just we are having very limited budget. But some of the devices are costly, so just we need a huge capital for implementing the smart grid. At the same time, there are a large number of load demand because of the industrialization. So just we are for that also you have to look into it. Okay, I stop at this point. These are the major challenges in the smart grid technologies. If you are having any questions, please.
So sorry for interrupting, sir. It is Muthukumaran from NSI Hyderabad, sir.
Please, sir.
Sir, actually.
Hello, your voice is not clear, sir.
Sir, right now it's okay, sir. You are able to hear my voice, sir?
Yeah, it's now it's okay, sir.
So it is Muthukumaran calling from attending from NSIC Hyderabad. So actually,
yeah, nice to meet you, sir. Yeah.
So actually, I also working on the smart grid project. So my research area is also on smart grid project. So actually,
okay.
When coming to the because a big when you are going for a big data concept analytics data, so there was a algorithm we can use where we can able to avoid this kind of problem. So if you're going for big data, because in your presentation in your presentation you have given that the data analytics is one of the challenging, but the challenging can be mitigated. The challenges can be mitigated, no, sir?
Yeah, it can be mitigated. That's what even just if the computer science also is coming to the picture, then this obviously can be mitigated. But the thing is that the computer science engineer also can able to understand the application. That's very much important. Even that's what I have taken a one PhD scholar with the computer science background. She's working on the virtual energy storage estimation in the smart grid. Actually, I need a person who is good at the coding and networking side, so that I can give the input of electrical system, so that they can able to understand. Because for understanding the electrical system itself, they need some 6 months or 9 months of time. So then only they can able to apply their knowledge to enhance further into the electrical system. So there is a gap. That's what we can say, the gap between specializations.
Okay. But
even a computer science person, they cannot directly jump into the electrical system, and they cannot do the wonders within a year. I mean, they need a proper practice, and he or he has to understand the system completely. That's what the problem comes here.
Okay. So that's because I'm also basically electrical background. I'm working. So big data is one of the challenging. I was working on it, making the coding, everything. So that's when after seeing your presentation, I was thinking that really it's challenging one, but it can be mitigated. Correct, sir? This big data, since the data is more, we can able to mitigate it. Correct, sir?
Yeah, exactly, sir. Once you can understand, then it will be very easy to do it.
Okay. Sir, one more thing, the final question from my end, sir. Regarding the data security, you're saying, no, sir. Actually, if you're going for a third-party option of like Amazon Web Service, AWS, as well as other paid version, then they have been ensuring that the data will be secured. That is
that's huge things to discuss, sir. But now mostly we are depending upon the third party of these data.
Yes,
so
sir,
in future, if technology supports, then we can come up with our own server and all, right? So that time this kind of problem will be solved. Even no, for example, if you think of it, in your home you are having a small network. If any person hacked that one, for example, in a TV, in the OTT platform, you are watching some channels or some program continuously. Depending upon that program, what program you are watching, then I can able to judge that who are in the phone. If sometimes if I'm watching the sports channel, people may think that okay, I'll be in a phone. So if any serials or any kind of for example cartoons or something, they may think that okay, only my wife and my child may be there. So in this case, in this way, it's not exactly, but there is a chance of predicting the correct information. So that they can able to include in that, and they can lead to some kind of activities. So this and all is a problem with that.
Okay. Okay, sir. Thank you, sir. Thank you for this thing, sir. Thank you, sir.
Yeah. Welcome.
Participants, if you have any questions regarding this session, please put your questions in the chat box.
So any other questions from the audience side? I'll be happy to answer. Even due to pandemic, we could not able to meet directly. It's my pleasure to meet you all in this platform, online platform. I hope you got some little bit information about smart grid. Thank you all. So if you have any questions, you can post it here, or just you can write a mail to me. So I'll be happy to answer to your queries.
Yes, sir. Thank you, sir. So far, we received only the positive feedbacks, and so till now we didn't receive any questions, sir. So thank you all for your thank you very much for your highly informative session, sir. And one more question is: any best simulation tool to work on?
Sir, just I want
grid,
to say something here. The smart grid is not any kind of, suppose if you want to build some smart grid model, you can use MATLAB itself. That's more than enough. So if you want to work on the power electronics part of that smart grid, I mean, here the smart grid is a system. That's it. It's a huge, or we can say it's a large system. So in the large system, you can devise the what we can do is just we can make the partition, and we can take that partition and we can work on it. Some people, those who are working on system level, for example, energy management algorithm or optimization, you can take the system. So we can use the M file to write the codes, or you can use MATLAB for simulation. That's enough. This is the best tools to do it. Right? Yeah.
Yes, sir. Thank you, sir. And now I would like to call upon Dr. N. Vinny. Yes, sir. Dr. N. Vinny Anthony Grace, Associate Professor of E&I Department, to propose the vote of thanks. Ma'am, Vinny, ma'am.
Yes, ma'am. Ma'am, am I audible,
Yeah.
ma'am?
Yes, ma'am.
Okay, ma'am. A very pleasant evening, one and all present here. It gives me immense pleasure to propose a vote of thanks on this occasion. I, on behalf of the Department of E&I and on my own behalf, extend a very hearty vote of thanks to our resource person, Dr. K.Vijayakumar, Assistant Professor, Department of IIITDM, Kancheepuram, for gracing his busy schedule and delivering us excellent information about smart grid architecture, its applications in detail, and also its research opportunities. Sir, we are really enriched with your knowledge and presence. I also would like to thank all the participants for their active participation in today's all the three sessions. Thank you, one and all.
Thank you.
Thank you. So
thank you, sir.
Thank you so much. Shall I leave, ma'am?
Yes, sir. Yes, sir.
Yeah,
Thank
sure.
you, sir.
Yeah, thank you all. Thank you. Bye.